Hi all, this is Srikanth. Today I will walk you through mobile OTP authentication, how an authenticator app generates time-based codes for secure login without needing any network connection. We will cover why email and SMS OTP have limitations and how mobile OTP solves them. And we will walk through a real-time banking scenario for both registration and login and explain how TOTP works under the hood. So TOTP is basically the protocol under how the mobile OTP actually works using Google Authenticator. And we will also discuss about the business value and the advantages. Now, today, most multi-factor authentication uses email or SMS to deliver a one-time password. It works, but it has some real limitations. So, email OTP depends on mail servers. So, let's say delivery can be delayed by seconds or even minutes. SMS OTP requires cellular signals, and it's vulnerable to the SIM swapping attacks, where someone ports your number to their phone. So both require a working network connection. And if the user is in the basement or in the flight or even in a poor coverage area, they simply cannot receive the codes. The OTPs will not be accessible. Now, what if the code was generated right on the user's phone when there is no network and there is no delivery involved and there is no cost involved? Now, that's the solution that we're talking about, the mobile OTP using the TOTP protocol. So that's exactly what mobile OTP does. It uses the TOTP standard, the time-based one-time password, the same protocol used by Google Authenticator, Microsoft Authenticator, and Authy. So during a one-time registration, the server and the user's authenticator exchange a shared secret. And after that, the app generates a six-digit code every 30 seconds just using the secret and the current time. So it completely works offline. There is no SMS gateway involved, no email server involved, and no internet needed on the phone. The code is generated locally on the device. And since the code changes every 30 seconds, and if someone sees it, it will be useless within half a minute. And this is the flow actually what happens. When the user first time tries to log in after the mobile OTP is enabled, the website of the bank walks him through a one-time registration. He enters his username, password as usual, and after the password verification is done, bank shows a QR code on the screen. This QR code contains a shared secret key. We will see what this shared secret key in detail in the demonstration going forward. And user opens his authenticator app, say Google Authenticator in our example, and scans the QR code. The app stores the secret and immediately starts showing the six-digit code with a 30-second countdown timer. User types the current code from the app into the banking website. The server verifies it matches and the registration is complete. His phone is now linked. This only happens once. From now on, user's authenticator app will always have a code ready. Now, the next day, when the user tries to open the bank website, he will enter his username and password, and the bank verifies the password and asks for the second factor authentication. Now, over here, user will open the Google Authenticator on his phone, and it will start showing the six-digit code with the countdown showing the remaining seconds. Now, user types passcode into the website. The server independently generates the same code using the same shared secret and the same 30-second time window. When the code matches, the authentication will be success and the user will be given the access. The whole thing takes about 10 seconds. And here's the key part. User's phone did not even need the internet or the cellular connection for any of this to happen. The code was generated directly on the device. He could have been on an airplane mode as well. Now let's see how the TOTP actually works. Under the hood, it's elegant in its simplicity. During the registration, the server generates a shared secret and encodes it as a QR code. The user scans it with their authenticator app, here the Google Authenticator. Now both server and the app have the same shared secret. At the time of login, the app takes two inputs. One is a shared secret and other the current time. And this is divided into 30-second time window. It runs on an HMAC SHA-1 hash function on these inputs and extracts the last 6 digits. That's the OTP code that we're talking about. The server does the exact same math independently. If the two codes match, the user is authenticated. No data was transmitted between the phone and the server. They both arrived at the same code using the same formula and the same clock. Now, in this approach, there is no delivery cost involved, zero delivery cost, no SMS charges, no email infrastructure involved, and this always works offline. Users authenticate anywhere. Strong security, the secret never reveals after the registration. So this is basically an industry adopted standard compatible with Google Authenticator, Microsoft Authenticator, and Authy as well. This is always fast and reliable. The code is always ready. And this is the comparison between the email OTP, SMS OTP, and mobile OTP. So let me put all three side by side and understand the pros and cons. Coming to the delivery mechanism, email goes through mail servers and SMS goes through cellular gateways. While coming to mobile OTP, it is generated right on the device. So coming to the network, both email and SMS need a connection. Mobile OTP works offline. It doesn't need any connection. And coming to the cost, email requires email infrastructure and SMS costs per message, often the biggest line item. And mobile OTP costs nothing. So the codes are generated for nothing. And coming to security, email can be compromised if the inbox is hacked, and SMS is vulnerable to SIM swap attacks. And with the email, with the mobile OTP, the secret never leaves the device after the registration. And trying to understand the combination analogy. So here's a simple way to think about it. Email and SMS OTPs are like someone mailing you the combination to your lock. So you have to wait for the letter, and anyone who intercepts it has your code. If there is no email connection and if there is no mailbox and there is no combination, email and SMS OTP doesn't work. Mobile OTP is like having your own combination generator. You and the lock share a secret formula. Your device calculates the combination instantly, right in your hand. No email, no middleman, and no one else can generate it. And the combination changes every 30 seconds automatically. Mobile OTP puts the code generation in your hands. No delivery, no interception, and no delays. And this is the business value that we're going to talk about. The business value is clear: zero delivery cost, no SMS charges, no email infrastructure, and this works offline. Users authenticate anywhere. Stronger security, the secret never travels after the registration. This is industry wide adopted standard, and this is compatible with Google Authenticator and Microsoft Authenticator. This is always fast and reliable. The code is always ready, and admin will have full control through the REST APIs. Now let's walk through a use case by using a demo application, and we'll show you how the mobile OTP authentication works. This is the Google Authenticator app, which we will see in the demonstration. And this is the sample demonstratable app where I configured the mobile authentication to work. Now let's do the transaction and understand how the actually flows work. So in the flow, we're going to register the user and we're going to authenticate the user with the mobile OTP using the Google Authenticator. Now let me try to log in with the user. There is a sample user. And before that, I would like to understand the network calls that are happening in the backend. So I will open the network tab to understand the flows, and I'll click on next. And it's asking for the password. I will authenticate the user with the password. Now the user is authenticated. And when I select the option, choose the mobile application to register, it will give me the QR code scan. Now, if you see the registration, there is something called the shared secret response. Now, this is something which is generated from the server. Now, what happens is during the registration, the server generates a shared secret and encodes it as a QR code. Now, the user scans it with their authenticator app. Now, both server and the app have the same secret. Now, I'll be using the Google Authenticator app, and I will register the user information by using the shared secret. Now I'll click on the manual entry option and I'll enter the shared secret value and I'll give some name. I'll save the account. Now you can see that the OTPs are getting generated and it has a time frame. Now what happens is this actually takes two inputs. One is the shared secret and the other one is the current time. And this is divided into 30-second window and it uses the HMAC SHA-1 hash function on these inputs and extracts the last 6 digits. That's how the OTP code is generated. Now you can see the OTPs are getting generated. I'll copy the code and I'll enter the code over here. And I'll also give the friendly name for the recognition. Now I have logged into the website, the sample website. So this is how the registration work. Now let me log out and try to log in one more time. Now when I try to log in post registration by entering the username, it is asking for password verification. And now it is asking for the OTP device, the OTP from the device. Now I'll switch back to the Google Authenticator and I'll fetch the code that is generated by using the shared secret. And I'll enter here and I'll verify. Now the account got logged in. So this is how the mobile OTP authentication with the Google Authenticator actually works. Now, just to summarize what just happened, during registration, the server generated a shared secret and encoded it as a QR code. The user scans it with their authenticator app, and now both server and app have the same secret. Now, at the time of login, the app took two inputs. One is a shared secret and the current time divided into 30-second window. It runs on an HMAC SHA-1 hash function on these inputs and extracts the last 6 digits. That's the OTP code. The server does the exact same math independently, and if the codes match, the user is authenticated. No data was transmitted between the phone and the server. They both arrived at the same code using the same formula at the same time. The advantages are there is zero delivery cost, no SMS charges involved, no email infrastructure, works offline, and users authenticate anywhere. It has stronger security. The secret never reveals after registration is done, and this is industry standard, and it's compatible with Google Authenticator and Microsoft Authenticator as well. Thank you.